is the rate of doing work. Power is the rate of doing work. So the rate of doing work is power. What will be the unit? The unit will be joule over second. And joule over second will be called from now on watt, which we use the letter W for that. Watts. That will be the unit of power. Before, to do work was fine. With the industrial and technological revolution, it's not only sufficient to do work. We have to do work, but we have to do productively or efficiently. So we have to do the work quickly. And for that, we need to have power, which is the amount of work you do over time interval, which is the W. If you want to get the average, will be delta W over delta T. This is the instantaneous power. But of course, if we want to get the power in terms of the force, we know that because work is the scalar product of the force times the displacement over dt, we can just get this and the derivative of the force over dt. If we have force, this, what is the, we can have, if the force is constant, we can pull out of the derivative, and we get that the force times the dr over dt. What is that? dr, not the d. dr, the change in position over time.
Velocity.
The velocity. Velocity times cosine of the angle alpha between the force and the velocity, or velocity between the force and the displacement. Force, alpha is the angle, the same thing, between the force particular and the displacement, delta r, which is the same direction as the velocity, or between the displacement or velocity, it doesn't matter. This is the definition. Another thing we need to know on power is that the power, or 1 horsepower, which you heard about it, is equal to 746 watts. This is the conversion factor between HP and watts. Good. So knowing that, we can start solving problems. So the problems, what will be the typical problems in power? You can get the same type of problems, but you need to get the work, and you get the work divided by the time. That will be the rate of doing work. For example, if we go to question
It's number 11. Number 11.
okay. 11, 12, 13, 14, all those questions are related to power, from 11 to 14. Okay, so in question 11, for instance, I said a 6 kilogram block slides along the horizontal surface, mu k given, for the block and surface. At what rate is the friction force doing work on the block at an instant when its speed is 4 meters per second? Do you have the speed? So we have two formula for power, either the derivative of work over time. If it's constant, you can use delta W over delta T for the average, or you can get the force velocity cosine of alpha. Let's first, the velocity is the velocity given?
Yes.
Is alpha given, or can we imply? How much is the angle between the object moving and the frictional force? 180. So you know that the frictional force is this way and the object is moving this way. It's 180. Good. So we have alpha, we have the speed. Do we have the friction? We have what? And what is the friction equal to? Mu times what? In that case, mg, because it's moving and that. So can you find the friction?
Yes.
So do you have everything to find the rate of doing work? So you can find. So what is the idea here in this type of question? You need to get the work, right? Or either the work and divide by delta T, but if we don't have time, you need to get the work by using the term, the force, delta V, the force, the velocity time, the angle between the force and the velocity. In this case, it's not given the work and it's not given the time explicitly, so I have to use this equation, unless it's given the force and the time. So you can get the force, which is the friction, mu times Fn. You can get the speed, which is given, and the angle. In the following one, a 2 kilogram block slides down the plane, inclined at 40 degrees with the horizontal, at a constant speed of 5 meters per second. The question, at what rate is the gravitational force on the block doing work? Again, at what? So in this case, this is an incline. What is the interesting? What is the interesting or the force that is interesting to us in this case? We want the work done or the rate of doing work by which force? Gravitational. This is Fg, right? And this is the velocity or displacement. What is the angle between them? This angle, but this angle is not given. The angle given is this. And they are not the same angle. So the best way to work the equation again is, if I am doing the rate of doing work, this is what? What is the one of the two components doing work? Fgx or Fgy? Fgx. So if I am able to find between Fgx and the displacement delta x, right? If I am able to find the angle between Fgx and delta x, will be easier to work with. Unless that you remember that it's this angle, so the angle between the two forces, which is easy to find, is the complementary angle. But if I go by the gravity, what is the force doing work? Mgx, I will use Mgx times the velocity, times cosine of the angle alpha between Mgx and the velocity. Mgx is going up or down?